This will be for the Khan Academy assignment, Finite Geometric Series. So it says the geometric sequence is defined by this formula. And they want us to find the sum of the first 25 terms in the sequence. So we're going to be using our summation formula. We've used this before. And if you recall that R represents the ratio, it's the number you're multiplying by each time. N is the number of terms, and A is going to be the first term. All right, but in this case, they're using subscripts to number each term. So I'm going to say that A sub 1 is going to be the first term. All right, so I'll just correct my formula right here. A sub 1 is just going to be the first term. And they wanted us to find the first 25 terms. All right, so as you can see, A sub 1 is our starting point. And then you're just taking the previous term each time and multiplying it by 3/4. So A sub 1 is going to be 8. And then right here, let's say you have A sub 2. And then you just subtract the 2 from 1. So A sub 2 is going to be A sub 1 times 3/4. Okay, so we're simply multiplying by 3/4 each time. So the second term is going to be 8 times 3/4. And then the third term is going to be 8 times 3/4 times 3/4, and so on. Okay, I'm just doing this to show you. You don't need to do this step. I'm just showing you. So in the formula, we have 1 minus R. Okay, R is 3/4 since we're multiplying by 3/4 each time. N is the number of terms. They said the first 25 terms, so the exponent is 25. That's divided by 1 minus R, so 1 minus 3/4. And that whole thing is multiplied by the first term, which is 8. Okay, so really, we just need to do this on the calculator. So I'm going to do 1 minus parentheses 3/4 to the 25th, hit equals, divided by parentheses 1 minus 3/4, hit equals, and then take that answer and multiply it by 8. Alternatively, you can use 0.75 in place of 3/4. And rounding off, I get 31.976. So this is the closest answer, answer C. They rounded off to 2 decimals. Okay, so here they want us to find the sum of the first 50 terms in this geometric series. Remember that N is the number of terms, so we're going to let N equal 50. And for R, we can clearly see, because they started at 1, that they are multiplying by 10 over 11. Okay, now if you ever can't do this in your head, just take one term and then divide by the previous term. So let's say you couldn't do this in your head. You would take 10 over 11 and then just divide by the previous term, which is 1. And of course, 10 over 11 divided by 1 is just 10 over 11. Okay, so we can see R is 10/11. And then finally, the first term, we'll call it A. You can call it A1 if you want. The first term is just 1. All right, so we're just going to use our summation formula to find the sum of the first 50 terms. All right, so you do 1 minus r to the n divided by 1 minus r, and the whole thing is multiplied by a, the first term. So that's going to be 1 minus r, which is 10 over 11, to the power of 50, divided by 1 minus r. And this whole fraction is going to be multiplied by the first term a, which is just 1. So on the calculator, I'll do 1 minus parentheses 10 divided by 11 to the power of 50, hit equals, and then divide by parentheses 1 minus 10 over 11, hit equals. Okay, so on the calculator and rounding off, I get 10.906. Let's look at the answer choices. Here you go, closest one to 10.906. Okay, here they want us to find the sum of the geometric series. So first you want to see what you are multiplying by each time. And as you can see, since the first term is 1, to get from here to here, we are just multiplying by 0.8. Okay, if you can't see it, take any term and divide by the previous term to get r. So 0.8 divided by 1 is just going to be 0.8. If you want to double check, you can take another term. 0.8 squared divided by 0.8 is just going to be 0.8. All right. So for n, the number of terms, let's see if we can figure this out. If you notice, the exponent increases by 1 each time, and it goes up to 19. So when there's no exponent, it's the same thing as if it's to the first power. Okay? And the number 1 is anything to the 0 power. So instead of 1, we can rewrite this as 0.8 to the power of 0. Okay, that's the same thing as 1. So you see the exponents, they count from 0 all the way up to 19. Now, if it was 1 through 19, there would be 19 terms in the series. But since it goes from 0 to 19, n is going to be 20. Okay, so there's 20 terms in this series. And the first term is a, and that's just 1. Okay, once you have this, then it's easy. You just use the formula. So the summation is going to be 1 minus r to the n over 1 minus r times a. Okay, so that's going to equal 1 minus r, which is 0.8, to the n, there's 20 terms, and then divided by 1 minus r, so 1 minus 0.8, and a, the first term, is just 1. So we're just multiplying this whole thing by 1, which doesn't change anything. So really, we just have to do this part in parentheses on the calculator. Okay, I do the numerator first, I hit equals, and then I divide by parentheses 1 minus 0.8. Okay, on the calculator I get 4.942. So let's look at the choices. And answer C is the closest, 4.94. Okay, on this problem, they're using sigma notation. So like we did on another exercise, we're plugging in for k, starting at the value 0, and then increment by 1 each time until we get to 19. So the first term is going to be negative 4 times negative 2 to the power of k, but k is 0. And then we add negative 4 times negative 2 to the power of k, but we use 0, so now we use 1. And then negative 4 times negative 2. We used 1 for k, and now we're going to use 2. And it continues. Okay, so all I did was plug in for k in this equation here and increment the exponent by 1 each time, because that's what this means right here. You start at 0 for k and you increase it by 1 each time. All right, so the initial value, a, this is negative 2 to the 0. We know anything to the power of 0 is just 1, and negative 4 times 1 is going to be a negative 4. Okay, so that's our first term. And as far as r is concerned, you want to see what you're multiplying by each time. Well, since the exponent is on the negative 2, we can clearly see we're multiplying by negative 2 each time. Okay, if you want to double check, like I said, you take any term and you divide it by the previous term. So right here, this would be negative 4 times negative 2, which is 8. And we said this was negative 4 times 1, which is negative 4. And if you do 8 divided by negative 4, you would get negative 2. So that's going to be the value for r. And finally, we want n, the number of terms. Okay, well, we start at 0 and we go to 19. All right, if it was 1 through 19, that would be 19 terms. But since it's 0 through 19, that's going to be 20 terms. So now we just use the formula. 1 minus r to the n divided by 1 minus r times a. Okay, we have 1 minus r, which is negative 2, to the power of n, which we said was 20, divided by 1 minus r, 1 minus negative 2, and then that whole thing is times a. So this whole thing is times negative 4. So on the calculator, I'll do the numerator first, hit equals, divided by parentheses, 1 minus negative 2, hit equals, and then times negative 4 at the end. Okay, I get 1,398,100. Let's look at the choices. There you go, answer B. Okay, once in a while, if you get a really big number, it might be in the form of scientific notation.